Imagine this, waking up tomorrow and discovering that the latest smartphones are no longer being shipped. Car manufacturers have halted production. AI companies are delaying new products. Stock markets are reacting. Governments are holding emergency meetings, and nobody seems to explain why. There are no natural disasters making headlines, no global war dominating the news cycle, no obvious crisis that the average person can see. And yet, something has gone wrong. Something so important that industries worth trillions of dollars are suddenly paying attention. Now imagine learning that the cause of all this chaos is something smaller than your fingernail. A tiny piece of silicon, a semiconductor chip. At first, that sounds impossible. How could something so small have so much influence over the modern world? But the more you look, the stranger the story becomes. Because semiconductors just don't power your phones. They power your laptop, your car, the hospital equipment doctors rely on, the satellite orbiting over your head, the bank systems processing trillions of dollars, artificial intelligence models reshaping entire industries, even military systems protecting some of the world's most powerful nations. Modern civilization doesn't simply use, it runs on them. Most people never think about them until something goes wrong. Here's what's fascinating. For decades, semiconductors were treated as just another technological product, a component, a tool, a piece of hardware hidden inside a larger machine. But somewhere along the way, that changed. Governments stopped looking at chips as products and started looking at them as strategic assets. Because in the 21st century, the ability to compute is becoming the ability to compete. The country with the most advanced chips can build more powerful AIs, develop more advanced military systems, strengthen cybersecurity, accelerate innovations, and potentially shape the future of the global economy. Computing power is becoming geopolitical power. And suddenly, the race to build better chips isn't just a business story anymore. It's about influence, security, and national strategy. And the future balance of power. But here's where things become more surprising. The entire global economy depends on semiconductor supply chain so fragile, so interconnected, and so concentrated that a single disruption in a single region can affect billions of people. A drought in Taiwan, a factory shutdown in South Korea, new export restrictions between major powers, a geopolitical crisis in the Pacific. Any of these events could ripple through the industries around the world, delaying products, rising prices, and slowing innovation. And this is because the chip industry is largely invisible. You don't see the factories producing advanced processors. You don't see engineers designing microscopic circuits. You don't see the raw materials traveling across the continent. You don't see the machines so advanced that only one company on earth can manufacture them. Behind every smartphone, every AI breakthrough, and every cloud service lies one of the most complex industrial ecosystems humanity has ever built. A system involving physics, chemistry, material science, global logistics, advanced manufacturing, and increasingly geopolitical competition. Because today, a silent battle is unfolding beneath modern civilization. There are no soldiers marching through cities, no dramatic speeches announcing at the beginning, no deadly headlines explaining its significance. And yet, some of the most powerful nations are investing hundreds of billions of dollars into it. Not over oil, not over gold, not over territory, but over technology that powers the modern age. At the center of the struggle are the United States, China, Taiwan, and a handful of companies most people have never heard of, but whose decision can influence the future of the global economy. Because this isn't just a story about technology, this is a story about power, control, innovations, and invisible systems holding modern civilization together. Welcome to Yond Studio, where we break down systems shaping modern world, from technology to geopolitics, to business and infrastructure. Not just what is happening, but why it matters, because beneath every headline, there's a deeper story. And today, you're uncovering one of the most important stories of the 21st century. The global war over chips. Let's get into it. The modern chip industry began with a problem. In the 1940s, computers were numerous. They filled entire rooms, consumed huge amounts of electricity, generated immense heat, and they broke down constantly. Machines like ENIAC were technological marvels, but they were so impractical. If computing was going to be part of our everyday life, something had to change. That changed in 1947. Inside Bell Labs, three researchers developed a transistor, a tiny electronic switch, capable of controlling electrical signals. At first, it seemed like a breakthrough for engineers. In reality, it would become one of the most important inventions in human history. Because unlike vacuum tubes, transistors were smaller, faster, more reliable, and practically more efficient. So, for the first time, computers began shrinking. And once electronics became smaller, everything changed. A decade later, engineers discovered something more powerful. Instead of writing thousands of transistors together by hand, they could place an entire circuit into a single piece of silicon. The silicon chip was born. What once required rooms full of equipment could eventually fit into the hand of your palm. And the semiconductor industry entered a race that defined the model world, a race towards miniaturization. Then, in 1965, Gordon Moore noticed a remarkable trend. The number of transistors engineers could fit onto a chip was doubling at extraordinary pace. More transistors meant more computing power. And for decades, that trend continued. Each generation of chips became smaller, faster, more powerful, and often cheaper. This became known as the Moore's Law, and it quietly fueled the digital revolution. As chips improved, technology exploded. Personal computers entered homes. The internet connected the world. Mobile phones became smartphones. Cloud computing emerged. Artificial intelligence became possible. Every major technological breakthrough of the modern era rested on the same foundations: more powerful semiconductors. And as society digitalized, dependencies on the chips grew. Banks needed them, hospitals needed them, factories needed them. Eventually, modern civilization itself began to run on semiconductors. But there was a catch. Making advanced chips became extraordinarily expensive. Building cutting-edge fabrication plants required billions of dollars. No single country could efficiently dominate every stage of production, so the industry globalized. America became a leader in chip design, Taiwan became the manufacturing powerhouse, South Korea specialized in memory chips, the Netherlands developed critical lithography technology. The system became faster, more efficient, and incredibly successful. But it also became deeply interconnected, because now a disruption in one part of the world could affect everywhere. And as governments begin to realize how dependent they become on semiconductors, a new question emerges. What happens when the foundations of the digital world is controlled by a global supply chain no single nation fully controls? That question will transform semiconductors from a technology story to a geopolitical one. For most human history, power came from things you could see: land, armies, natural resources. The countries with the most territory, the largest populations, or the richest reserves of oil and minerals often became the most powerful. But the 21st century is different. Today, power is increasingly coming from something invincible: computing power. And computing power depends on semiconductors. The chips inside your phone, your laptops, or your car have become one of the most important strategic assets on Earth. Because whoever controls advanced computing helps shape the future of artificial intelligence, cybersecurity, economic growth, and national security. And that realization has changed global politics. What once was a technology industry has become a geopolitical battleground. The story begins with the United States. For decades, America had undisputed center of semiconductor innovations: the transistor, the integrated circuit, the microprocessor. Many of these breakthroughs that created the digital age emerged from American laboratories and companies. Firms like Intel, NVIDIA, AMD became leaders in chip design. Firms like Intel, NVIDIA, and AMD became leaders in chip design. The United States dominated the software ecosystem, the intellectual property, the engineering talent. It built foundations of modern computing. While America continued designing many of the world's most advanced chips, something important happened. The manufacturing gradually moved somewhere else. To reduce cost and increasing efficiency, production increasingly shifted to Asia. At that time, it seemed like a smart business move. Few realized it would eventually shape global power. Out of that shift, one place became extraordinarily important: Taiwan. And at the center of Taiwan's rise was a company most people never heard of: TSMC. While other companies competed to design chips, TSMC focused on manufacturing them. A perfected foundry model, and over time, it became a factory behind the digital world. Today, many of the world's most advanced processors are manufactured inside Taiwan's facilities. The chips powering your iPhone, AI systems, the laptop you're currently listening to me on, all depended heavily on a single company operating on a single island. And that creates an uncomfortable reality. A significant portion of the global economy now depends on one geographic location. If production stops, the consequence won't stay in Taiwan, they will spread across the world. China noticed this vulnerability, and from Beijing's perspective, it presented a strategic problem. The world's second largest economy depended heavily on foreign semiconductor technology, advanced processes, manufacturing equipment, critical intellectual property. Much of it came from outside China's borders. In an era where competing power increasingly determines economic and military strength, the dependence looked dangerous. So China launched one of the largest technological investment programs in modern history. Billions of dollars flowed into it: domestic chip manufacturing, research and development, engineering talent, and AI infrastructure, just for semiconductor independence. The objective was simple: reduce reliance on foreign technology, build national capacity, and gain greater control over China's technological future. As China accelerated its ambitions, the United States responded. And that's when the semiconductor industry stopped being just a business story to become a geopolitical one. Washington introduced restrictions on advanced semiconductor technologies, not only chips themselves, but also tools required to manufacture them. The logic was straightforward. Modern AI requires numerous computing power. Advanced computing power requires advanced chips, and advanced chips require specialized manufacturing technology. Control the technology, and you influence who can access the future. Suddenly, semiconductors weren't just products anymore. They became instruments of national strategy. And then, there's one of the most fascinating parts of the entire story. Because one of the most important companies in the semiconductor industry isn't American, isn't Chinese, and isn't Taiwanese. It is Dutch. ASML. Most people have never heard of it. Yet, without ASML, the modern chip industry will struggle to function. The company produces extreme ultraviolet lithograph machines, the machines used to manufacture the world's most advanced semiconductors. They are so sophisticated, so difficult to build, and so technologically complex that no other company has successfully replicated them at scale. Which creates a remarkable situation. The world's largest economy, world's biggest technology companies, and some of the most powerful governments on earth all depend on a company located in the Netherlands. And that reveals the deeper truth behind the chip war. No country truly controls semiconductor industry. Not America, not China, not Taiwan, not Europe. The entire system is built on interdependence. And while the interdependence creates decades of innovation, it also created vulnerability. Because when the world's most important industries depends on everyone working together, a distraction anywhere can become a crisis everywhere. And that's exactly where the world soon will discover. Take a moment and look around you. Your phone, your laptop, your smartwatch. Most people see finished products. What they don't see is the invincible systems holding them all together. Because modern semiconductors aren't just simply manufactured. They are assembled through one of the most complex industrial networks ever created. A single advanced chip can take months to produce, not days, months. And before the chip reaches your device, it may travel across multiple countries, passing through hundreds of suppliers, and undergo thousands of manufacturing steps, all for something small enough to balance on your fingertip. The world's most advanced chips aren't built in one factory or one country. They are built by an ecosystem. Materials from one region, equipment from another, designs from Silicon Valley, manufacturing in Taiwan, packaging in Southeast Asia. Everyone performs a high specialized task, and every step depends on every other step working perfectly. It's less like a supply chain and more like a giant machine spread across the planet. Nowhere is the complexity more invincible than tools used in manufacturing chips. At the center of the story is ASML, a company most people have never heard of. Yet without it, modern computing would look different. ASML builds extreme ultraviolet lithography machines, the machines used to carve microscopic circuits into silicon wafers. Each one costs hundreds of millions of dollars, contains hundreds of thousands of components, and represents decades of scientific research. They are also complex that no other company has successfully replicated them at the same scale, which means a critical piece of the global technology industry depends on a single supplier. But many of them don't manufacture the chips themselves. They are companies like NVIDIA and AMD. They design one of the most powerful chips, but many of them don't manufacture these chips themselves. Instead, they rely on specialized foundries. And that brings us to Taiwan and to TSMC, the company that has quietly become the factory behind the digital world for smartphones, for data centers, for cloud infrastructures. Many of the technology shaping modern life depends on chips produced inside the TSM facilities. And for years, the system worked remarkably well. Then came 2020. Factories slowed. Ports became congested. Supply chains stalled. At the same time, millions of people suddenly needed laptops, servers, networking equipment, and home office technology. Demand exploded. Production struggled to keep up. And for the first time in decades, there wasn't enough chips. The shortage spread faster than almost everyone expected. Electronics companies faced delays. Industrial manufacturing struggled to source components. Products that took weeks to deliver suddenly required months. Some required more than a year. A tiny component was distracting trillion-dollar industries. Nowhere was the impact more invincible than the automotive industry, because modern vehicles aren't just machines anymore. They are computers on wheels. Every major system, navigation, braking, engine management, sensors, driver assistant technology depends on semiconductors. A modern vehicle can contain thousands of chips, which created a remarkable situation. Automakers had factories, workers, materials, customers waiting, but they couldn't build cars because they were missing a component smaller than a postage stamp. No chips, no vehicles. It was simple, but the shortage revealed something even more important. A large share of the world's most advanced semiconductor production was concentrated in one place, Taiwan, and specifically TSMC, the company manufacturing many of those chips powering artificial intelligence. Which raises an uncomfortable question. What happens if the production stops, not for a few days, not for a few weeks, but for an extended period? The consequence won't remain in Taiwan, would spread through the financial market, technology companies, defense systems, supply chain industries, and the economies across the globe. For decades, the semiconductor industry was celebrated as a triumph of globalization. Fast, efficient, innovative, and it was. But the shortage exposed something hidden beneath the surface: vulnerability. Because when a system becomes this interconnected, a problem in one location can become a problem everywhere. And the world discovered something it had never fully appreciated before. Modern civilization doesn't just use semiconductors. It depends on them. Which leads to a very bigger question. If chips have become this essential to economic power, national security, and technological leadership, what happens when nations began competing to control them? Throughout history, great powers have always competed for resources that defined their age. At one point, it was fertile land. Control the land and you controlled food. Later, it was trade routes. Empires grew rich by controlling the flow of goods across oceans and continents. Then came coal, then steel, then oil. Entire economies were built around them. Wars were fought over them. Global influence often belonged to whoever controlled the resources that mattered the most. But in the 21st century, a different resource is taking center stage. Not oil, not gold, not even land. Computing power. And computing power begins with semiconductors. Because behind every online payment, every GPS signal, every cloud computing, there's a chip. Tiny, invincible, yet increasingly essential. Which means semiconductors are no longer just technological products. They've become strategic infrastructure. and the governments around the world have started treating them that way. Nothing has accelerated this shift faster than AI. A modern AI system doesn't run on ideas alone, it runs on computation, a large amount of it. Behind every breakthrough AI model are massive data centers filled with specialized processors working around the clock. Without advanced chips, modern AI simply won't exist. No LLMs, no image generators, no advanced automation system, which means something remarkable has happened. The race of AI has quietly become a race for semiconductors, because the countries that control advanced computing power may gain an advantage in shaping the technologies of the future. But AI is only part of the story. Modern military power increasingly depend on computing power too. Today's weapons are not just mechanical machines. They are computers. Missiles rely on processors. Drones rely on chips. Radar systems process enormous amounts of information every second. Without semiconductors, many modern defense systems simply won't function as intended. And that's why governments now view chips as a national security issue, not just an economic one. For years, many governments believe globalization has solved the problem. The markets will handle production, supply chains will remain stable, technology would keep flowing. Then reality intervened. The pandemic exposed vulnerabilities, chip shortage disrupted industries, geopolitical tensions increased, and governments began asking uncomfortable questions. What happens if critical chips become unavailable? What happens if technology powering our economy is produced somewhere else? The answers triggered a global response. The United States invested heavily in domestic manufacturing. China accelerated its push for self-sufficiency. Europe, Japan, and South Korea expanded semiconductor initiatives of their own. For the first time in decades, countries weren't simply competing for technology. They were competing for technological resilience. And yet, there's a problem. No country controls the semiconductor industry alone. Not the US, not China, not Europe, not Taiwan. The software comes from one place, the machinery from another, the materials from somewhere else. The modern chip is a product of a global ecosystem. And that's the paradox at heart of the chips war. Every nation wants technological independence, but the industry itself was built on dependence. The very system that created extraordinary innovation also created extraordinary vulnerabilities. And that leaves the world facing a difficult question. Can countries truly become technologically independent? Or has modern civilization become too interconnected to separate? Because the answer may determine not just the future of semiconductors, but the future of global power itself. For more than half a century, the semiconductor industry lived by extraordinary promise. Every few years, computers became faster, phones became smarter, technology became cheaper, and somehow engineers kept squeezing more power into a smaller piece of silicon. For decades, it felt almost magical. The future always seemed bigger, faster, and more powerful than the present. This relentless progress became known as the Moore's Law.
Moore's law is the observation by Gordon Moore in 1965 that the number of transistors on a microchip doubles every 2 years, driving computing power. It all starts here, with the silicon wafer. This paved the way for the exponential growth predicted by Gordon Moore back in 1965.
History has seen this before. When steam reached its limit, humanity turned to electricity. When mechanical systems reached its limit, we turned to computers. And now, as traditional chip scaling slows down, a new race is beginning, not to build smaller chips, a race to reinvent computing itself. Artificial intelligence, quantum computing, advanced packaging, new semiconductor materials, specialized processors, entirely new architecture. The question is no longer, how do we make one chip faster? The question is, how do we build the next generation of computing? Because the future of many belongs to those who rethink the system entirely. Every major AI breakthrough you've seen, from chatbot to image generators, depend on one thing: computing power. Behind the scenes are vast centers packed with advanced processors. Thousands of machines working around the clock, consuming an enormous amount of energy, performing trillions of calculations. And that has transformed semiconductors into something far more valuable than the ordinary technology. They have become the fuel of the AI era, because whoever controls advanced AI hardware helps determine who can build advanced AI system, and whoever leads in AI may gain advantage in shaping the technologies of the future. And here lies the central paradox of the chip war. Every major power wants technological independence, but modern technology was built through global cooperation. The chip inside your phone may involve American software, Dutch machines, Japanese materials, Taiwanese manufacturing, and components from several other countries. No nation built the ecosystem alone. The world built it together. The cooperation created incredible innovation, but it also created vulnerability. And now, governments face a difficult challenge. How do we make technology more secure without breaking the global system that made it possible? The answer may define the next decade. This is Yond Studio, where we explore the system shaping the modern world. Not just the headlines, but the infrastructure beneath it.